We're now going to take a look at the rectangular coordinate system, a system that's used for graphing in 2 dimensions. Now, for some time now, you've been able to graph in 1 dimension. In 1 dimension, we can graph simply by using the number line. For example, if we want to graph the real number 5, we can mark the number line to be centered at the origin, which is 0, and then we can count off 1, 2, 3, 4, and then 5, and we can put a dot out here at 5, and we've graphed the real number 5 on the number line. Similarly, we could graph, say, a -3. We can count off to the left, -1, -2, -3, and we can put a dot there, so we just graphed 2 real numbers. But when we need to graph in 2 dimensions as opposed to 1 dimension, 1 real number line isn't sufficient to do that with. So what we actually find ourselves using is 2 number lines. We have the traditional horizontal number line, and we position vertical to that, so to create a right angle where they intersect, a second real number line. The horizontal line is normally called the x-axis, and the vertical is typically called the y-axis. These 2 axes, like I said, meet at a right angle here at the center, and the point at the center is called the origin. To graph a point on these 2 axes, we need an ordered pair. That means we have to have an x and a y value to be able to graph, because we are graphing in 2 dimensions. That's why we need the 2 values. Now, these axes are marked off in a very predictable fashion. The x-axis on its right-hand side is where you find the positive values, just like you did on the other number line. On its left-hand side is where you find the negative x values. On the y-axis, we're going to let the positive values go upward, and we're going to let the negative values be oriented downward. These 2 number lines, when positioned in this way, allow us to graph ordered pairs. Say, for example, I wanted to graph the ordered pair 2, 3. The 2 being first means it is the x value. The 3 being second means it is the y value. So to graph this point, I would come up from the 2 right here on the x-axis, come over from the 3 on the y-axis, note the point at which they intersect, and that would be the point that I graph. So then, for another example, if I wanted to graph the point -3, -1, that would mean I would come back to -3 on the x-axis and come out from -1 on the y-axis and plot the point where they intersect. Now, the way these axes are laid off, we'll take any flat surface, like the flat surface on this computer screen, and divide it into 4 parts. These 4 parts, since there are 4 of them, we call them quadrants, and they are laid off in a counterclockwise orientation. This is quadrant 1, this is quadrant 2, this is quadrant 3, and down here is quadrant 4. So these points that we've graphed, you can actually indicate in which quadrant they fall, simply because, like with this first point, the positive value followed by the second positive value told us, or implied, that this was a point that fell in quadrant 1. The second point, being made up of 2 negative values, told us that that point would fall in quadrant 3. Now, just as a technicality, if we were looking at a point like 0, 2, we would go to that point by not going left or right on the x-axis as the 0 implies, but we would go up 2 on the y-axis, and that point technically is considered not to fall in any of the 4 quadrants because it is on the axis between them. We can say that it falls on the positive side of the y-axis, but that again does not put it in any one of the 4 actual quadrants. It is just on one axis or the other if you have 0 in either the x position or the y position. So this is what how our coordinate system is made up. This is the coordinate system that we will use to graph in 2 dimensions in algebra classes and beyond. And what we need to be able to do, one skill that they'll want you to develop is, well, the first one, most obvious, is being able to plot points, as we've already looked at here. Another one would be able to take points that have already been plotted and sort of identify their x and y value. For example, if we were to look at that point falling over here in quadrant number 2, and we wanted to come up with the x and y value that correspond to them, we would note that it lies directly above the 3, the negative 3 actually. So its x value is clearly negative 3. It is in line horizontally with 1, so that would be its y value. And that's, again, one of the first things they want us to do is to be able to plot points like we did with these two, and to take a point that's already been plotted and come up with its x and y value as we did.